Alright. Let's see. Are we live? It looks like we are live this time. Okay. If we are live, which it looks like we're live, let's go ahead and get started on this. So... the last time we left off, we had added our generate buttons, which means we are... looks like my text is really small. Whoa, I do not want to go that big. I don't... let's reload it, I guess. So far, our main function looks pretty nice. Something I thought about that we could do is we could actually move the PyGame initialization into the game initialization. Thinking that you've only felt this way from me. You always tell me I'm the only one you want to be with, so why can't I believe it? And then the only thing we have to pass in is our initialization, and then we just run our loop. Very clean, very clean. I like this very much. I almost want to blow this up for you guys. It's because it looks even better. Trying to look at this in like the preview. I just hate looking at my text this large. We're gonna have to settle for this. This is as big as I can go and not lose my mind. I need to find something else to listen to though. This ain't gonna cut it. Gonna be a little bit distracted based on delay. It's random.
I can't tell the difference between lies and dreams. There's chaos in you. Embrace it.
That's interesting. Glad to see Kid Cudi still getting some respect. Wow. Linkin Park mix in this. It's interesting. Alright, we'll go with this. This is chill enough. And I'm gonna look up my previous concept because there was a part in here where I terminate the search. And let's see, find path. Nothing really matters. Okay, got too many tabs open on my other screens. I've got to kind of like do away with some of this. Just realized that my PowerShell is like ridiculously large. Okay, I think this is good enough. Cool, good enough. Alright. So We have the ability to create start and end locations. One thing we wanted to do is look at so a new quadrant. You know what we'll do is we will only allow this check to take place. What we're gonna do, instead of creating a list and trying to pathfind multiple lists, we're going to say that when we create a new start, we will check if self, if not self.walking. And then in the path, we will set a variable that sets self.walking equals false. Something else that we're going to do is we're going to create an array of current steps. Current steps. How about we call this walking squares, and then current steps equals a number. We might be able to factor this out. But the idea here is that we let's move these up here. So I was actually just talking to somebody about this. I like creating these little like boxes that are easy to read. Because as things become more complex, it's easy to lose things. Endpoint spawn function. Then as we build more complex systems, we kind of have that. It's easy to navigate this stuff. So hard for me to keep things minimized like this or zoomed in. I'm gonna have to zoom out one more. This is hard for you guys to see, I apologize. I'm trying to watch my stream and see. It doesn't look too bad. Index to position, position to index, and find path location. How about we change this name? I still don't like this. We're gonna call this find path location, find available path. Find valid path. No, find available. We're just going for any available path. Alright. So the first step in this is to define map end point distance self. And what we will do is we're gonna need a function for this. We're gonna have to find next step and we're gonna have to define a find path, the parent function. This is gonna be our super function essentially. We're gonna have to determine an exit condition. Determine if we are at an entry point. We'll come back to these. Determine if we are mapping the distances or we are finding a path. So this is where we would say self.map endpoint distance. We would say that if the length of self.walking squares equals 0, then we will append the is it exit? Just so we can get rid of these. So we find a path. So there's two sub parts in the pathfinding. So we're going to have have mapping functions, and then we're going to have pathfinding functions. these are distance mapping functions versus pathfinding functions. And so the first thing is we're gonna the logic is that we're gonna go from the end point and we're gonna step our way through the map, and every square gets a distance, and then from our start point we can just take the next shortest distance all the way back to the end. So a square will end up needing a entropy value, and I'm just going to store these ahead of time because I want to map everything, and we can just trigger this to true and that'll help with logic later, and then we'll walk it back the other direction. And we can trigger this to true also to help shorten our paths, or so we don't retrace multiple steps multiple times. So, if we don't have any walking squares, and let's just say mapping squares, because that makes more sense. And let's call them mapped squares because, or no, mapping, because it's a verb. We are mapping these squares. And so the logic is these are our squares, and then while we're mapping our squares, we will we'll call this current distance. And while I could call this a distance, I don't want to call this a distance because actually, you know what, let's call it distance. In my head I didn't like it, but it'll sound good later. There's a quadrant, we don't have to deal with UI right now. I don't know if we need map. I think we're good on main too, so I cannot do this zoomed in. Ugh. Okay. And I'm not getting anything done here. I'm like going in circles in my head. So what we're going to do is say if the length of the mapping squares is 0, we're going to set self.mapping. Do we have a mapping condition? So walking is the path. Self.mapping equals false. And so when we will use this to determine if we're mapping the distances. So if self.mapping, then we will map the endpoint distance. Else self.find exit. So that's where we will define our find exit, which also does nothing. map endpoint distance. Map. Sure, we're gonna call it a single distance, even though it's an entire map. I actually would rather call this endpoint distance map, even though it's a function, it is also an object. And really we're assigning a distance, an endpoint distance to the map, which is really an array of squares, but whatever. And if we hit this point, in my previous code I returned here because I called this in a loop, because for every update I was finding the path, but I think we can do better. And I don't think we need an exit condition here. So, current edge. Current step. How do we call this? Is that how we want to do this? That's one way we could do this. But that's only going to give a single step. And I don't want to do that. So the reason I did this before, I created a cleanup function. And we'll come back to that. This is kind of a, there's better ways to do this. But this is simple enough. It shouldn't be over engineered. So we're gonna say for square in current step. We're gonna call this current iteration. Kind of. We could come up with better names, but this is fine for now. So, are we gonna use the index? Yes, we are. What we're gonna do, so here we insert the first square, which is the exit square. When we go to map the endpoint distance, we're gonna take the square in the current iteration, and we're gonna say that the distance equals the square's square, and this is gonna actually be index, so square index we're gonna get that distance and we're gonna just add one to it, and then we will say that the next squares equals get next squares, and we don't have that function yet, so find next distance, find next squares, and all we're gonna do and I think I know how I want to do this in my head, but I'm gonna double check my previous code and kind of like compare how I did this before. So I created a handful of utility functions in my previous one, and I'm glad I checked. There's 3 things that we want to check for, or 4 things. So is in path, and theoretically we could use this in our pathfinding. Oh, these go up here. But this is direct indexing, so there's no point in calling another function to directly index, regardless of how compiler optimizations might work. This is sufficient. We want to say that define is in bounds, and I don't think that's what we want. We don't want the length of squares. That would be valid. That would be a valid check, but we should never iterate past the length of squares, so we just want to make sure that our index is less than the number mapped squares x. I think it's actually should be -1, but we're gonna leave it like that. If we run into problems here, we'll know. Pretty sure that's right. We could say is in bounds or is in map, either one's fine. And then the define is mapped, and we're going to check if it's mapped. While we're here, we might as well say is walked, and then we will find next squares. And so the first thing we're going to do is define check mapped square and is in bounds. We want it to be in bounds, and is in path, and is not in map. Is mapped. So the first thing we're going to do is say that current x, current y, you get the index of the positional index. We will create a bunch of index functions, and then we will also create their counterparts. It's not necessary, but xy in path self xy It doesn't really make sense to use that one, but we have the opportunity to. This is the one we really want. XY is mapped, and XY is walked. And these kind of don't, it's kind of stupid to do that, but whatever. This is the one we really want, and not that we need that, but instead of converting to index multiple times, which is what we're doing here anyway, we have the ability to call this multiple ways. Because what we are going to do is say this. We are going to create a bunch of positions. But instead of doing it like this, we're going to say position top, position right, position bottom, and position left. And we will start at position left, and actually we'll swap bottom and top just because that's the standard for I believe that's the standard for actually might be a little confused, but for the left we will say current x -1, and then the y stays the same. The bottom would have the same x, and the y would be +1. The right would be +1, and the top would be -1. So that was close. And then this is where I did this wrong. This needs to be here. Find x squares. And we will say that the current squares equals a blank list, and then we will check I wonder if we can do it like this, or let's do it like that. Yes, I think this is what we want. But that's not exactly what we want. So we want to say, oh right, so this is getting rid of the tuple, I believe, and then just unwrapping it to straight Cartesian coordinates. I'm not sure. That's right, I might be wrong. C style code would tell me that this is actually directly referencing this, not making a copy of it. If that's the case, I feel like I should be able to do this, but I feel like that, if it's unwrapping, I need to learn more Python. We want to return this if it's inbounds, if it's in a path, and if it is not mapped. And it might be easier if we convert this to index. And we just do indexes and bounds. And then each one of these would become positional arguments. That looks a little bit easier. Iterator magic and casting. Okay, so to find a path, we determine if we're at an entry point, meaning we have no squares mapped. If how about we say, so if we have not mapped, and if not mapped, we can get rid of the mapping. Yeah, we can get rid of mapping, because if we have already mapped it, we don't if we have already mapped it, we're going to skip both of these and just find the exit. That's what we want to do. I think that we're going to try to control it from the top, but we'll see how this loop plays out. And then we've implemented that, so I guess we can leave that comment there. And so we endpoint distance map. So the reason that we have this loop on the outside is because we want to call this from the main function. We're going to have our game.update, which actually runs in the UI. The UI updates. We get the time. We draw. We render, and then this is where we want to do we want to do it here, or do we want to do it in the map? I feel like the map has a draw function, but I feel like the I mean, this is just a wrapper function, but I feel like that's a little bit more explicit because we only want, like, say, 15. We don't want to do less than 15 frames per second. That's painful to look at. I think we're gonna leave it here. We could call Pathfinder from here. Straight to the UI, but it feels more natural to have the map call the Pathfinder. It also gives me a layer of abstraction if we want to yeah, so the reason we return here is because on the first iteration, we're going to map the mapping squares equals 0, and we have not mapped, so we're just going to pin the exit on the first iteration, and then we're going to return, and then on the next iteration we'll come back and skip this because we have a number greater than 1. And we will end up back in this condition, and so the return is to avoid race conditions. The reason we will end up in this condition again is because if, and this is where the cleanup function comes in, if we end up in a dead end, and we can't escape the dead end, we want to collapse the dead end, or an unreachable area. We want to collapse that area. We want to set the mapping squares back to 0, and we want to set the mapped back to, we want to make sure we are not mapped yet. We don't want to end up in a condition where we freeze our loop. And here we also need to say that if actually we can say what we can do here is we can say if self.mapped and so and not self.walking, we're just gonna return if we are already mapped, we don't need to do anything. If we have already found our path, we don't need to do anything. And then really we can move this because this condition will be here. And unfortunately we'll do this every time unless we pass this to the parent, which in that case we'll do it at the top level every time. So it's slightly inefficient, but whatever. This is just to get things rolling. Cool, that's what I was gonna say. Okay. So we map the endpoint distance, get the current iteration of squares. We can go ahead and clean up the points. But I don't want to follow the old code. We're also going to have to implement some color coding. But right now, we go through the squares. We increase the distance of the current square by 1 because our next step will be 1 greater. we find the next squares, which becomes a list of squares based on if the square is valid. We make sure that it is not mapped, it is a path, and it is in the bounds. So we don't want to step over any paths we've already stepped over. We don't want to go outside of the path, and we don't want to try to access something outside of the map or loop around to the wrong side of the map. I almost feel like it would be better see, this is better with XY because then we can't accidentally go past the width. We can't wrap around to the wrong side, which can happen if we convert this to an index. We could get some really funky values. So as much as I just did all of this, as much as I hate doing all of this again, we're gonna get rid of these. We're gonna pass this in as it is. And we're gonna convert these right here. We'll check the index directly here instead of converting them inside the function, which really doesn't make a difference, but I am just over it at this point. Okay. So we get the squares, we check if they're valid, we return an array of squares. We never access these things. So for each square in our iteration, we're going to find a next 4 squares. So back to our horrible drawings. What we're going to do is we're going to check for a square, and then we're going to check the squares around it. And then for each of these squares, we're also going to check the squares around those. And we're going to continue to do this for each iteration. And each one of these gets a +1. And so this would be 0, 1, and then 2s, and so on. And the reason this works so well too, just skipping ahead, is that if you can guess and are following along, then when we go to walk back, if we look at this value and we look at the 6 surrounding locations, this would be the next immediate step, and then this would be the next immediate step. And so it creates like this little bit of exponential pathfinding that gives us the shortest distance like every time. And like this one, the quickest way would be here, and then we end up here again. So there's a little bit of weighted directional bias. They're obviously going to go to whichever path is considered shortest. It might not necessarily always be shortest, but it will be shortest relative distance based on the start location. So back to it. So if the length of the next squares is 0, we could continue. I guess that's one way to do it. We could just nest the entire logic into that if statement, but this will be fine. for next squares, we do not want to assign a distance. We want to say that so the next thing we're going to do is say that the distance equals the distance. And if you noticed that on this next iteration, we'll get the distance back and add one to it. So that's where we're getting the distance from. This will be added to the list of squares. Is why we need to implement a cleanup function. Cleanup mapping squares, because why not? We're actually going to call this self. And then we'll define mapping square. And we will come back to that. We want to set the mapped value to true. No, we don't want to do that yet. We want to set the outline to 0. Sure, we'll say that it's true. Because we don't want to accidentally step back into this square. So we are making sure that we have the index here. We want to set the color to green. Do we want to say green? What colors do we have? We're using blue for water, red for target, green. Let's pull up a color picker. We're gonna pick a color. I'm gonna pick this, like, sure, we'll go with these colors. I'll go with like a mustard color. Let's go like a burnt orange color. Or let's make it like a little bit of a hazard color. There we go. These are going to be our stepping color. So we'll go, we'll call this orange. It's fine. That was pretty close, actually. Then we will call this orange. So if we run this now, what happens? Game object has now attribute exit index. On path line 16. So what is it called then? End index. Where did the exit index come from? Game object has no attribute. Get x squares on line 146. Get x squared. Find x squares. check mapped squares. Takes 2 positional arguments, but 3 were given. Because it dereferenced this like I thought.
I was born to be free.
Could say X and Y. That'll be fine. There's not really a point to this, but it's explicit, I guess. Invalid color argument on line 29 and line 71. Oh, we don't call the color function. We call we don't call the color variable. We gotta call the set color function. So it already turned all this area to orange. That's not what we wanted. But it is drawing our orange color. But it's not doing what we wanted. And this one did it almost immediately. Because the camera calls the render function. Render should not execute our pathfinding. Should it? Should the UI call the pathfinding? That kind of makes more sense, actually. That's odd. See, this is what I meant, that you can end up in the wrong location. Well, we are staying in the bounds. There's a bug here, though. The first thing that's bothering me, though, is that the UI should not be updating. Whoa, that just mapped basically everything. So there's something interesting going on. Like, it's like it's skipping areas. This should not be going that fast. It should be walking. Oh, you know what we're not doing? We're not clearing our squares. So when we clean up the mapping squares, this is where we need to do check if we are in a dead end. Actually, that needs to take place up here. Trying to make sure we didn't hit a while loop or anything, because it shouldn't be doing all of these at once. It should be doing one step at a time. For every clock tick, every 5 frames per second, so 5 times a second, 5 steps a second, we should be taking one more step. I'm trying to see if there's something I remember. I forget. So to clean up these endpoints, we want to say that I'll be right back. Alrighty, I remembered to unmute this time. I appreciate your guys' patience. For now, just to see if this works, I want to say that what is this called? Mapping squares. Sure. And all we're gonna do is we're going to say for squares and mapping squares. We're gonna set the squares to gray again, just to see. We will to do interpolate colors. So we're gonna create a color mapping. And then do we self.mapping squares. We'll just remove that item in the list. And I think that's all we have to do. So we're gonna add it to the list. We're gonna do some changes. We're gonna pop it off the list. And then that allows us to make a working copy of this array. Is there a copy? Is that a thing? Or a shallow copy? I think we can just do this. I think this counts. Pretty sure. So let's run this and see. Well, now nothing happens. Also, I don't see an endpoint. Maybe we just had a buggy instance. Oh, you know what we need to do is set when we create where's our map? Where do we create the map? Create the map, set these points. These are not walkable points. This is a path. When we create our start and end location, where is that function at? Is that in the pathfinding? Right. So when we create a start and end location, we need to say that the squares at the start index is not a path, and it has been walked, and it has been mapped. And we need to do this for our end location also. And maybe this, we don't need all of this, but some of you might do this and come up with your own. But we need to make sure, see right there, we had our little red dot and then we killed it. We popped it off the map. So what did we do wrong? This just creates a copy of. Let's try copy. Let's see what this does. I've never really used copy. So now we are getting something. Whoa. So it's not exactly right. I see what's happening now. Well, I kind of see what's happening. Let's run this again. See, in this case, it just canceled itself out. And somehow here it started in two different locations. Well, this is kind of cool, even though it's not what we want. And it's not right either. Still interesting to see it walking. Okay. So, what did I do wrong here? And some of you probably have already solved this. If it's in the map, if it is in a path and it is not mapped, this should return true. Let's just say X and Y for sanity's sake. So X minus 1, Y plus 1, X plus 1, Y minus 1. If if the next square is in the self dot start index, self dot end index, we're just going to return. I feel like we could do this check up here. Let's check these functions. Let's make sure these are right. So if our x is less than the number of map squares and it is greater than 0, and y is less than the number of map squares y and greater than 0, so that's valid. If the index is walked, it is mapped, it is in bounds, so we're not even checking this one. So let's just do away with all the ones we're not checking. Fuck, I hate Copilot sometimes. We're not checking any of these that... God damn it. Excuse my language. So we don't have a problem finding an available path. That works. We know that works. So far, these seem to be working. The one thing that's just weird is that we're just kind of like skipping steps. So each next step should look at the squares next to it, but it's not. Is this function right? Position to index? That's right. So what am I doing wrong here?
Part of a movement, and yes, sometimes it moves slowly, but in the end, I've already pointed out.
What's going on here? It's gotta be something simple. I need to take a break real quick. I got some work stuff I gotta get done. I just got hit up for work. I also need to take a break from this because for whatever reason, it's gotta be something simple. My head's just not having it. I'm pretty sure there's a breakdown somewhere in here. And some of you might probably find it already. There's a specific reason we're not stepping across corners. But we'll come back to that. Maybe it's the way I'm doing this. But this should at least keep us from, well, no. There's something going on here because every once in a while it'll step back onto itself and it'll end. And it might be the way that we're, I don't know. Anyway, we'll come back to this. I need to take a break for a little bit, and I appreciate you guys tuning in. Appreciate you guys following along. If there's anything I can help with, let me know.